our first speaker is from HoneyHive, is Mohak Sharma from HoneyHive. HoneyHive makes it easy and repeatable for modern AI teams to test, evaluate, simulate, and observe their AI applications and make them safer, trustworthy, and more reliable for their users. HoneyHive simulates real-life AI applications to detect bugs before they reach production. And today we'll hear about how from one of their founders, Mohak Sharma. Mohak, welcome to the stage.
Hey, thanks, Sujat, for having me. Let me just start sharing my screen.
Great. I'm going to remove myself from the stage now.
Perfect. Okay, hopefully everyone can see my screen. And yeah, thanks for having me here today. Today, I'm going to be talking about techniques for building LM evaluations that actually work in the real world. We've heard from a lot of users that LM evaluations are a net new way of testing AI applications. They're more scalable, faster, and cheaper than human evaluation. But one of the issues that we really hear is they're quite unreliable to actually be able to use in production. So today I'm going to be talking a little bit more about what are some techniques that you can actually use to build LM evals that really work for you and your specific domain and your use case. So a bit about me. I co-founded HoneyHive in late 2022 to build evaluation tooling for AI applications. Previously, I built the data and ML platform at Templify, which is a SaaS unicorn based out of New York. And at HoneyHive, I've really just had a chance to work with hundreds of teams building AI applications, from your major builders and researchers like OpenAI's and Anthropic's of the world to Fortune 50 enterprises to app layer infra startups. And in the chance, I've really had a chance to actually look at what kind of applications people are building, what are the evaluations that they are setting up, and how they're actually making them work for their use case. So let's dive in. Today, we're going to be answering three simple questions. What are LM evaluations? Can we actually trust them? And if so, what are practical strategies that we can use to actually align them to your domain and use case? So, what are LM evaluators? The basic idea really is using large language models as a judge to be able to evaluate the outputs of other large language model applications. This concept was first introduced by Anthropic with the constitutional AI approach, and also adopted by OpenAI with the super alignment team, where they use weak to strong generalization. And the basic idea is a smaller large language model can effectively govern and evaluate a larger large language model. There have also been other papers that came out in the last year, like NLG Eval is an example, Spade, which demonstrate really high correlation with human judgment and LM scores. In terms of sheer efficiency gains, our internal findings indicate that LM evaluators are roughly about 10x faster compared to mechanical Turk graders. They're also 10x cheaper, and they have roughly about the same accuracy and consistency compared to mechanical Turk graders as well. And so the promise of using LLM as a judge to evaluate the outputs of other LLMs really is faster, cheaper, and scalable assessment. And the end outcome, I think every team is trying to drive with LLM evals is automating wipe checks, manual iteration that people are doing today in spreadsheets and in the playground. But if you're building an LLM application yourself, you may actually have a very less rosy view of this whole space. The reason is we see two key challenges if you're actually building LLM evals in production. First is criteria drift. Really what we're seeing is LLM evals and LLM applications themselves are dynamic in nature. So your inputs are constantly changing. The failures that their application experiences also shift over time. And if you're using an API model like GPT-4, Anthropic's Claude, these companies are bringing constant updates to these models. So the models themselves shift over time. So a lot of users, which might be relying on frameworks like RAGAS, GEval, LangChain, et cetera, and which often rely on generic criteria definitions and they're static in nature, those evaluation criteria fall short because the evaluator's notion of good or bad no longer aligns with your domain expert's notion of good or bad. This is something which has been corroborated by the EvalGen paper that came out earlier this year by good folks at Berkeley. And they found that LLM evaluation criteria cannot be static. It needs to constantly evolve over time. And the assertions that you're defining within your code to test these LLM applications must actually adapt and evolve as the failure modes are evolving over time. And the main challenge really then comes down to how do you optimize and maximize the true positives from your LLM evaluator while minimizing the false positives? So this is just the first challenge that we see, really, criteria falling short of what users actually see in production. The second bigger challenge, in our opinion, really is the evaluation data sets themselves lack test case coverage. So what I mean by that is when you start building an LM application, most users start with 20 to 50 handcrafted examples of test cases that they test their prompts against. But the problem is, as soon as you put your application in front of your users, the kinds of user queries that you're going to see from your users might be widely different from what you had planned and actually tested your application for. And so the static data sets themselves fall short because the manually generated data sets, the test cases, are not representative of the kind of user queries you're actually seeing in production. And the result is data set drift. Your eval data set no longer represents actual user scenarios. And that ultimately renders your entire eval meaningless. We see a very common example of this when it comes to things like grammars, where a lot of users might have perfect grammar when they're crafting their 20 to 50 test cases. But the users in production are actually, perhaps they're on a phone, and they're actually inputting these queries in lowercase, using abbreviations, using incorrect grammar, perhaps even using different languages if your application is global. And so, again, if your test cases are not representative of those kind of user queries that you're actually seeing, the entire evaluation is rendered meaningless. A second example I've seen, particularly in financial services, is when you're trying to do, let's say, question answering over 10K SEC reports. And you might have designed your entire application for tech companies, public companies, and their valuation methodology in mind. But now suddenly your users start asking about companies in healthcare or manufacturing. You might not have the relevant data in your vector database to actually be able to answer those questions, or simply the valuation methodology is different. So if you're not accounting for those sort of scenarios that your users are actually seeing in production and your data set itself is static, your entire valuation, again, is rendered meaningless. So how do we actually solve this? How do we get past this problem of static evaluation criteria, static data sets? Well, the answer really, we believe, is moving to a more dynamic and adaptive LLM evaluation system. The way you actually do that is by treating LLM evals as not static tests, but as dynamic systems. I think all of us coming from software engineering world have been used to defining tests in a static manner because the outputs are constrained in nature, so are the inputs, and the sort of errors that you can see in a particular function, they're very constrained. But when we're working with LLM applications, the inputs are completely unconstrained, so are the outputs. And so we need to actually treat our LLM evals as a dynamic system that requires continuous tuning and alignment with the evolving user needs. And how do you actually do that? Well, the answer really lies in your domain experts and users, right? Domain experts are the experts in what should be the right answer for a particular user query. And your users have their own expectation for the correct answers, what they should be. And so what we find is if you're building an LLM evaluator and you want to align that, the best way to align that is with your domain experts themselves. And the way you do this is you first run the LLM evaluations, the automated metrics, which is great. But then don't abandon manual evaluations. Whenever you have an automated score, actually look at the score, reason over it, perhaps critique the score yourself using thumbs up, thumbs down. Some companies even we have seen actually edit the end score. And that allows you to have a ground truth data set of what the correct score should be and what was the LLM generated score. And now you can use those two things to actually measure alignment between the LLM evaluator and the human domain experts. So you can use metrics like F1 score if you're capturing binary judgments like true or false. Or you can use Pearson-Spearman correlation if you're capturing things like on a scale of 1 to 5, how hallucinatory is the output. And this will help you quantify how well your evaluator is actually aligning with human judgments over time. The second thing that we found really useful is actually including a lot of good and bad few shot examples into your evaluator template itself. This just grounds the model, gives it more fine-grained context for it to be able to evaluate both the positive scenarios as well as the negative scenarios over time. Now, coming to the data set alignment problem. Here, we believe the best data sets actually come from the real world. So whatever your users are actually inputting into your system, that should be representative of your test cases. So as an example, what we've seen that really works for users is if you have some sort of automated metrics or you're capturing feedback from users in the form of thumbs up, thumbs down, you can use all the data sets, all the test cases where users gave positive feedback as a regression data set upon which you want to make sure as you're iterating, you're not regressing over time. And all of the test cases where users were not happy, you can use that as an improvement data set to make sure you're actually continuously improving your application as you're iterating over time. Some of the more advanced companies that we work with, we've also seen them use things like simulations, where they might design a end user simulation using the large language model itself and create different personas. So as an example, there are companies in the edtech space who use simulation for, let's say, a child, a fourth grader in India who's really interested in mathematics, as an example. And you can use those simulations to actually go out there and red team your application to make sure you're not regressing or you're continuously improving over time. So if you take a step back, the key idea really is to build reliable LM Evals. We need to treat them as dynamic human-in-the-loop systems instead of static systems and static tests, which is like an idea we really need to abandon from software engineering. And this is very much like how you build your core LLM application, right? You continuously collect the ground truth, iterate over time, and make sure your application is continuously improving. So how does HoneyHive fit into all of this? Well, we are a unified AI evaluation observability platform. Our main goal is to create a robust test-driven development and iteration workflow that really just ensures that your AI applications are reliable by design. The way we do this is by logging all of your real-world examples and scenarios from production through OpenTelemetry. So you have a sense of what exactly your users are actually inputting into this system. Second, we allow you to build LM evaluators within the in-app eval console. And you can actually align those evaluators with those real-world scenarios that you are collecting from production. So you can iterate on the evaluator prompt, you can add few-shot examples, and really make sure the scores that your LM evaluator is outputting are actually aligned with your domain expert's preference. Third, you can actually supplement LM evaluations and those automated metrics with human review. So users can actually go into the trace view, give thumbs up, thumbs down on the evaluation results, even correct them over time. And that allows you to measure alignment over time and actually improve your evals as you add more data sets, as you change the evaluator prompt, add more few-shot examples, or perhaps even fine-tune a binary classifier yourself. So yeah, that's my talk. Thank you for joining. And if you're interested in staying in touch, please connect with me on LinkedIn by just scanning this QR code.
Cool. Thank you very much, Mohak. We'll leave the chat about a minute or so to ask any questions. If there's no questions that come in, there might be some questions that are going to be private questions that are going to be asked directly through the Discord. If you see those, please answer those. If not, I will try to route those to you as they are asked. Someone has said that you have had an awesome presentation, so that's really good.
Thanks, Mike.